I want to talk about a concept in organic chemistry called conjugate addition. And in order to do that, we're going to look at what conjugate addition is, and look at some examples of that. And what we have to do is we're going to start by looking at an alpha-beta unsaturated ketone. This is the typical functional group that undergoes conjugate addition. You're going to see it in many different forms. So just as a means of introduction, what are we looking for in terms of unsaturated ketone? It is a carbonyl compound that is conjugated to a carbon-carbon double bond. Right? That's the basic framework that we're looking for. I want to just show a quick reaction on this. Let's just do a reaction where I would hope that you'd be able to do this product. It's the cyanohydrin formation using sodium cyanide and then some acid to catalyze the reaction. Whatever that might be. And what happens is the cyanide nucleophile adds to the ketone carbonyl pretty much as you would expect, and we get the cyanohydrin, which looks like this. Right, so the cyanohydrin forms and under the acid conditions. Now there's one small bit of information which I didn't include here, which is actually quite important for this reaction to occur. I'm not going to talk in too much detail about that now, but the reaction needs to be fairly cool, around about 10 degrees Celsius. If the reaction conditions are changed slightly though, and we take exactly the same thing, sodium cyanide with some acid, but now we do the reaction at 80 degrees Celsius, the product we get is something completely different. The product looks like this. So what has happened here? In this step over here, under higher temperatures, the nucleophile has added to this carbon of the unsaturated ketone and not this carbon over there. Here's another typical example of a conjugate addition. Well, first of all, if I had to take this substrate, let's not worry about what the R is. It could be an alkyl group, it could be many different things, even just a hydrogen. If we were to take this substrate and add, say, a Grignard reagent, and Grignard reagents and reactions are done in two steps. So we can use phenyl magnesium bromide, that's the nucleophile, the phenyl, and of course the second step is we will need to work up the reaction, protonate the intermediate, and so we'll use just a mild acid. So we do this reaction and the Grignard reagent reacts with carbonyls as you've been taught. The bond adds there and we get a product that looks like that. So this is just a normal addition to the carbonyl. But if we take that same set of conditions, the same set of Grignard conditions, so we've got phenyl magnesium bromide, and we just add a very, very small amount of a copper chloride catalyst, just maybe 1% of that, and do this in two steps. Again, we need to only after the reaction is complete work up with acid. The reaction product now is the conjugate addition, where the phenyl group has added to the beta position of the alpha-beta unsaturated ketone. And so the product will look something along those lines over there. So again, these are the two different options. We have either the standard addition, which we're very used to, or we are adding our nucleophile to the beta position of the unsaturated ketone. This over here, this step over here, your standard Grignard type reaction, is known as a 1,2 addition. And the conjugate addition is often also known as a 1,4 addition. And besides being called a conjugate addition, it's also often known as a Michael reaction. So these are the new terms that you need to learn in order to identify these reactions. So what is actually happening in this reaction? What is the mechanism of the reaction? Well, that's fairly simple, and I'm going to just show it by just a very generic example of unsaturated carbonyl compound. In fact, let's just use an aldehyde, so we're just doing something slightly different. The nucleophile, whatever it might be, and we've seen two examples so far. We've seen the cyanide, we've seen a phenyl group. Whatever the nucleophile might be, will add to the beta carbon, and the pi electrons in the unsaturated ketone are able to delocalize, because they're conjugated, they can delocalize onto the carbonyl group like that. And so once that happens, we get the first adduct. All right. Let's assume the nucleophile was negatively charged. So the nucleophile has added, we get this intermediate, and this intermediate over here you should recognize as an enolate. And of course an enolate can tautomerize back to the ketone, provided there's some acid around. Generally in these reactions there would be something like that. And so this can pick up a proton, and we get the final compound, the product. It looks something like that. So that's the mechanism. It's not terribly hard, but the important feature here is to recognize how these reactions occur, and then also to realize that these types of reactions can occur with a whole bunch of different nucleophiles. You can have we can use amines, so nitrogen type compounds, primary, secondary, or tertiary amines add, but they do it reversibly. We can add alcohols, we can add thiols, we can add halogens such as bromine, chlorine. In fact, you can even use aromatic nucleophiles as well, just something as simple as benzene. You need to activate this a bit, but you can get benzene to act as well. So any kind of nucleophile is able to do that. In order to understand what nucleophile and why we get a 1,4 addition versus a 1,2 addition, well, that is going to be the subject of the next lecture, and so I encourage you to watch that.